We'll be starting with the Taylor series method and we'll see what are the important Taylor series method. In this method, basically, this is a method of numerical. See, if you are having a problem like an initial value problem where dy by dx is equal to the function having two variables. See here, there's a function which is having x and y variable, so that y of x naught, okay, is equal to y naught. Okay, so that means x naught is the initial value. So y of 0 sometimes it can be written like 1. So that means basically what? X naught value would be equal to 0 and y naught value would be equal to 1. Okay, this is the meaning of this. Now this solution, okay, the solution of y of x, the solution of of y of x is approximated by the Taylor's formula, okay, by the series expansion. Normally, the proof does not come approximated, okay, by using power series formula, using power series, power series of x minus x naught, okay. So that is basically if you have to find at any other point, let's say y of 1.4 at any other value of y of x, then you can get it at y of x naught, okay, which can be y of x naught is nothing but y naught, correct? Plus, let's say x minus x dash, x minus x naught, that x naught is the initial problem, then y dash. So y dash, basically y dash here refers to y dash of x naught means dy, okay, and dx of y of x naught. Okay, this is the meaning of it. Y double dash means the double differentiation of this point. So that means d square dx square of x naught. Okay, so this is the meaning of here of this. Okay, this is your y. So x minus x naught, y dash of x naught plus x minus x naught whole square. Okay, 2 factorial y double dash of x naught plus x minus x naught whole to the power 3 factorial y triple dash of x naught and so on and so forth. Okay, so let's say we have been asked any question, okay, to approximate the Taylor series. Let's take a problem here. Okay, let's take this problem. Employ Taylor Taylor series method to find y at x equal to zero point 0.1 and zero point 0.2, okay, to four places of decimal in step size of zero point 0.1. Okay, so for given differential equation, let's say here that is your dy by dx minus 2y is equal to t to the power ex. Okay, and what is it? Whose solution passes through the origin? Whose solution passes through origin? Okay, origin. And once also find, okay, y of zero point 0.1 and zero point 0.2 by analytical method. So you have to do it by an analytical method. Let's go for it. Now, as soon as you see the question, okay, so as I have shown you, so here you look for the question. So it passes through the origin. Origin is this point where x would be equal to 0, y would be equal to 0, correct? Now, by the Taylor series expansion and by the given data, so dy by dx can be represented by y dash, okay, and minus 2y is equal to 3 balance. Then for subtract this equation, I can write y dash is equal to 2y, we go that side, plus 3 power ex. And what else is given? Given is y of now is equal to 0, because the point is origin, right? Origin is mentioned here. So therefore, X naught is also equal to 0 and Y naught is also equal to 0. Now I apply the Taylor series formula. So straight away y of x would be equal to y of x naught, your y naught value, plus x minus x naught, y dash of x naught, and the same formula, plus so on and so forth. X minus x naught ka whole square, 2 factorial, y double dash of x naught, as c. Now here look up till what value we have to apply. Okay, we have to see. He's asking us to get the correct up to the four decimal places. Okay, so Taylor series expansion, four decimal places. That means we have to apply this up to, let's say, uh, we can up to four decimal places. It's good enough. Okay, we can go for x minus x naught whole cube 3 factorial divided by y triple dash of x naught. Okay, generally up to this decimal places up to y triple dash of x naught will suffice. But if it is mentioned in the question, suppose if it is mentioned, okay, particularly like up to 4 degree or something like that, up to fifth degree, then we have to move ahead. But here, no such thing is mentioned. It only correct to four decimal places. So up to third degree would suffice here. Okay, actually, one more problem. What you have to do, you have to don't just take the y dash. Okay, and from there, 2y plus that is your 3 power. So, okay, just take this and just try to differentiate this. So this is see what are the values of x naught and y naught here. So we know x naught value is 0 and y naught value is 0. So put into 0, right? So then we know that this value is the first value, right? We look at y double dash. Now y double dash right? Differentiation y differentiating it was y dash was equal to y by 2, right? Again, differentiate this with respect to x. D by dx of 2 plus d by dx of t is constant in the term of differentiation of e bar x from beginning. This will become 2x y dash. Because what is y dash? Y. So, and this number is y dash. And this remains the same in power x. Again, we put the value x equal to 0 and the y value is equal to these values you have to again put in the question. Now, so we have to get the question. You have the y dash value. So y dash cannot value in what we have seen. So no one can use no value. In the case of x, the same value is given. So this will be 10 into the power. This will be 6 plus 3, this will be 9. So the value that we will have, but it will be in the value. Okay? Now we can write the full dash. So now we can make the y dash so it's by doing of this. Okay? So if you are doing so, so, three factorial y triple dash of 0. Okay, y triple dash of 0. Now, when you are going to put this value, y of 0, you know what is the value for y of 0 in y of zero point 0.1. If you just are putting in this equation, so we already know y of 0 value will come as you go to the equation and just put the equation y of 0 value is 0, right? Because x not was 0 and y not was 0. So y of 0 is 0. So you put this value 0 over here and this becomes your zero point 0.1. Y dash of 0 we just now saw was equal to 3. So you'll just multiply this with 3, right? Then plus again this is zero point 0.1 because this value is 0. So zero point 0.1 whole square 2 factorial is 2. Y double dash of 0 we just now found out that was equal to 9. So multiply it with 9 plus x cube zero point 0.1 ka cube 3 factorial and y triple dash of 0 was equal to 21. Just multiply this with 21. So you will get y of zero point 0.1 value to be equal to, if you just put in the calculator, you will get 3.3485. Okay, same thing you do with y of, see, when you calculate the y of zero point 0.2 value, now y of zero point 0.2, same thing you do in y of zero point 0.2, right? Now, in order to get the y of zero point 0.2 value, how we are going to go for it, right? Now, in this case, we shall compute y of zero point 0.2. The equations will remain same, but here there's a trick that you have to remember. So as you see, y dash was equal to 2y plus 3 e power x. But here, the initial point that you have to assume in this case, okay, that is your x naught value should be equal to zero point 0.1, okay, and y naught value which you got y of, see, which you got this y, see, this y of zero point 0.1 is equal to, now you got here, na? See here, y of zero point 0.1, that means y of x naught is equal to your y naught, right? So this x naught value happens to be zero point 0.1. So y naught value will be equal to your 0.3485. Just you have to just use these values. Now the same thing y dash of zero point 0.1. See if you differentiate this value. So first the first value is straightforward. Okay, that would be 2 twice into y of zero point 0.1 when you are going to put y of zero point 0.1 value. So that value is 0.3485. Okay. So 2 into 0.3485 plus 3 into see 2 into y of zero point 0.1 value you put there plus 3 into e power 0.1. So y of zero point 0.1 value, right? Y of point 0.1 value here is this value 3.4285. 2 into 0.3485 plus 3 into e point 0.1. So you get this value as 4.1025. Same thing you do with y double dash. That would be your 2y dash plus 3 e power x. Okay, same thing y triple dash. That would be equal to 2y double dash plus 3 e power x. Now, in the similar procedure, if you are going to calculate, this will come to 25.9965, and this y double dash value will come as 11.3405. Now, if you just put the same way that I had put previously, right? So y of zero point 0.2 value will be easily able to calculate. So y of zero point 0.2 will be, now the initial point is not 0, zero point 0.1 plus zero point 0.1, right? Then y dash of zero point 0.1, y dash of zero point 0.1, then here it would be 0.012. Okay, that is the square that I've already expanded. Y double dash of zero point 0.1, then here the cubic term 0.01. Okay, 3 factorial is your 3 into 2 into 1. So this is 6 and y triple dash of zero point 0.1. Already we calculated these values. So y of zero point 0.2 would be equal to 0.3485. Put the value plus zero point 0.1. Okay, here this thing 0.40125. This value will come as this, and then you have 0.01 to the power 2, 11.3405 plus 0.001 to the power, sorry, divided by 6, 25.9965. You just calculate this value y of zero point 0.2, you'll get as 0.8108. Now, in this case, if you have to see the value also analytically, right? So dy by dx, see, by analytics, we'll see. So dy by dx minus 2y is equal to 3 e power x. So just put it in this form. Dy by dx plus py is equal to q. Now, if you're comparing this with p, so you'll get p as minus 2, right? Compare this with q, so you get q as 3 e power x. Now this analytical solution to this equation is given as y into e power p dx. Okay, integral q e power p dx plus c. So just calculate this value e power integration of, see, p value is there minus 2, no? Minus 2 dx. So minus 2 dx will become minus 2x, right? So here you just put 3 e power x, and this value is your into e power minus 2x dx plus c. Here also this value will become e power minus 2x, right? E power minus 2x. Now it is under integration, constant comes out, okay? So this is 3 power ex minus 3 power, so this will become e power minus x dx plus c. So integration of e power minus x would be equal to e power minus x divided by minus 1. Okay, so this will become minus 3 e power minus x plus c, that is equal to y e power minus 2x. Okay, so this is the value that you got. So you can write from here this equation as y is equal to minus e3 into e power minus x divided by e power minus 2x, and divide the c also by e power minus 2x. So you know that e power minus 2x is nothing but 1 by e power 2x. So if you are dividing it in the multiplication, it will go up minus 3 e power minus x into e power 2x. And here also c into e power 2x. This is equal to y. So minus x 2x will become plus x. Okay. So if you see here, so it will become minus 3 e power x plus c e power 2x. This value is equal to y. Now, what is your condition? First condition is your y of 0 is equal to 0. That is your x naught is equal to 0 and y naught is equal to 0. So the general solution means here the first value is 0. That means minus 3 into e power 0 plus c into e power 2 into 0. You know e power 0 is equal to 1. So this becomes minus 3 plus c. Okay, is equal to 0. So therefore the value of c happens to be equal to 3. Okay, now you see, therefore y would be equal to 3 into e power 2x minus e power x. Okay, now if you put y of zero point 0.1, so that means you have to put 3 into e power 2 into zero point 0.1 minus e into zero point 0.1. Just calculate this value in the calculator, you will get 0.3487. Same way, y of zero point 0.2 would be equal to this 3 into 2, okay, into zero point 0.2 minus e into e into zero point 0.2. Let's put so 0.8113, which is the same as our previous thing. Hope this is understood. You have understood this Taylor series. Now, if it is asked till fourth degree, then we expand up to 4 factorial. Okay. Rest questions I've shared in the PDF. This is the method how it has to be done. Thanks a lot.